Welcome to another math prompt of the week. For today's question, we are asked to find the closest integer to 100s, where s is the minimum value for this expression.
Pause the video now if you wish to solve it. Keep watching the video once ready.
We are going to provide you two different ways to solve the problem. Now, the first method we are going to discuss is the triangle inequality, ABC. So what we know is that AB plus BC is greater than AC. So we are going to use this idea to solve the problem. Let fx, since each of these has a factor of 2, I'll take the 2 out and become a square root 2. And this will be square root x squared minus 6x plus 10, x squared minus 4x plus 5. I complete the square here, so this will be x minus 3 squared plus 1. This is x minus 2 squared plus 1. I'll let p to be 3, negative 1, and a to be x0, b to be 2, 1. Now we look at the xy coordinate. P is 1, 2, 3, and this is negative 1. So this is P. This is a fixed point. A is x0. So A is somewhere here. Let's say this is A, x0. B is another fixed point. And this is B, 2 and 1. This is actually equals to the length of PA. This is actually equals to the length of PA. And square root of x minus 2 squared plus 1 is actually the length of AB. From the triangle inequality, this will be greater or equals to PB, where PB is here. If we move the point A to this particular point, then we'll get the minimum value. So in this case, the minimum value is equals to the length of PB. So the length of PB is equals to 1 squared plus 2 squared. And that is 5, so this is square root of 10. So now we know that from here, S will be at least equals to 10, and it is achievable. So S is equals to square root of 10. Note that the square root of 10 is about 3.162. 100s will be closer to B, 316. So this is the method 1. For method 2, we still need the expression here, plus an idea from vectors. Again, from triangle inequality, using vectors, let's say this is A and B, and this is C and D, then this will be equal to A plus C, B plus D. Let's call this as ABC. AB plus BC will be greater or equal to AC. And AB is actually equal to square root of A squared plus B squared. And BC is C squared plus D squared. And it will be greater than A plus C squared and B plus D squared. So we are going to apply this idea here. But before that, let me write it one more time so that it's easy to refer. By writing x minus 3 squared to 3 minus x squared, it does not change the value. but it will help me to apply this idea directly. So according to this inequality, this will be greater than or equal to square root of the sum of the corresponding coordinates. So the sum here will be equal to 1, and the sum here will be equal to 2, and therefore this will be equal to square root of 5. So again, the answer is square root 10 here. When can the equality holds? The equality holds if and only if this B move to here. In that case, AB must be parallel to BC. So equality holds if and only if AB is equal to K of CD. I'm going to show you another way using this method to get the answer. You write as square root x minus 2 square plus x minus 4 square, x minus 3 square plus x minus 1 square. Okay, then in order to use this, I will change a little bit. I'll write it as 2 minus x squared and 4 minus x squared. And this one I do not change it. So again, this will be greater than or equal to the sum of this square. So it will be 2 minus x plus x minus 3 square. And this is 4 minus x plus x minus 1 square. And this cancel off, so this is -1. -1 square is 1. And this is 3, so it's 3 square. So this will be square root of 10. Again, you get the same answer. Now we are going back to method 1 again, using coordinate geometry to show that the answer indeed is equal to square root of 10. I'll let P to be 2, 4, A to be x and x, and B to be 3 and 1. This will be the graph. 2, 4 is somewhere here, that is P. X is actually on the straight line, y equals to x. So this is somewhere here, this is A. And B is equal to 3, 1. So this is 3, 1, this is B. So back to this again. The first term is actually equals to the length of PA. And the second term is actually equals to the length of AB. Okay, using triangle inequality, we know that this will be greater or equal to PB. The equality holds if and only if A is the point here. The length of PB is equal to square root 2 minus 1 square, so that is 1 square, and this is 3 square, and this is square root of 10 again. One very important thing about this question is when you have inequality, you have to make sure that this number is achievable. Otherwise, you can't say that it is a minimum value. It's not yet to say that it is a minimum value. So that's the end for this question. Hope you enjoyed it, and I'll see you again next Tuesday.